calculated. And more than likely, in your lifetime, you're probably going to have a credit card if you don't already have one. And what we're going to look at today is how is interest calculated, which is critical to understand if you aren't able to pay your credit card bills. If you're able to pay them, that's all good. But if you can't pay them, that's when things get expensive. So if we look at this first problem here, it says, suppose you charge $1,000 on a credit card that charges 12% annual percentage rate, APR. We want to find the account balance after 5 years. And what we're going to do is we're going to try to do this by evaluating a single expression. Write down the expression as well as your answer. Well, we start with $1,000. What's going to happen is we're charging 12% annual percentage rate. That means that we're going to end up paying more money than $1,000 if we don't pay off our bill. So this is a percentage increase problem, which means we're going to have 1 plus 0.12, and we're going to be looking at this over a period of 5 years. So once we know that, then we can type this into our calculator, and we've got 1,000 times 1 plus 0.12 to the 5. There's our single expression. And when we do that, we'll get this value. Remember, we're dealing with money here, so we want to round to the nearest hundredth, and we end up with $1,762.34. So if we wait 5 years, that's going to be expensive whatever we bought for $1,000. Because it's $700, almost $800 more dollars. Now, if we look at the next one here, if interest were charged at 12% APR, instead of once a year, the same card would charge us 6% interest twice a year. Semi-annual, twice a year. We want to find the account balance after 5 years by evaluating a single expression. Well, we're still going to start with $1,000. And we're still going to get charged more, so this is a percent increase problem. But this one is going to be 1 plus 0.06. But it's going to happen twice a year. So this is going to be 2 times 5. So twice a year. And if we go back then and we type this into our calculator, we've got 1,000 times 1 plus 0.06, close the parentheses, to the 2 times 5, and we get 1790.85. So just looking here, $1,790.85. We're rounding to the nearest hundredth because that's how our monetary system works. So we're looking at the 7, which means we're going to round that 4 up. So we calculated once a year, we ended up with $1,762.34. We calculated twice a year, we ended up with $1,790, even more money. And let's take a look at this here. What we've done so far is we've done the annual. In the annual, we said the interest rate is going to be, or the interest is going to be calculated once per year. And our interest rate was 12%. And the interest after X years was 1,000 times times 1.12, 1 plus 12% to the x. And what we calculated a few minutes ago is we calculated the $1,762.34. Well, then we changed it up a little bit. We said semi-annually. And in our problem, the semi-annual told us that we are going to be calculating twice a year when we calculate that. And we then get charged 6% twice a year. And the formula that we used is 1,000 times 1.06 to the x. And when we calculated it for the 5 years, we ended up with the $1,790.85. Our next one here is quarterly. How many times do you think we will calculate the interest quarterly? So a lot of people are showing me 4. And you are correct. So if we're getting charged, if we're going to be calculating interest 4 times per year, what percentage are we going to use, Matthew? And how did you get it? Okay. Anybody else have another way of saying it? Hayden?
So, start out with 12%. Quarterly, it's kind of like
It is. It's not even kind of like. It is. So to get the 6%, we took 12% divided by 2. To get the quarterly, to get that percentage, we take 12 divided by 4. Is how that's being calculated. So if we would come over here and we actually, not if we, or we're going to take 1,000, and this time it's going to be 1.03 to the x. We got to type this one in. 1,000 times, it was 1 plus 0.03 to the 5. Except that it's going to be to the 4 times 5, because we're going to do that 4 times a year. And now we're going to pay $1,806.11. Jordan?
I have a question for setting up like balance after a year for like the 2 and 4 for the equation.
Mm-hmm.
For the 2, what if there would be like a 2 next to the x?
Thank you. Got to write the 2. And then I typed it in, and I forgot to write the 4 times. We're going to calculate this 4 times. So go back and check that on your paper and make sure that you didn't make the same mistake that I did. We do. We have to do that twice a year. Now we have to do this 4 times a year. And again, I typed it in correct into my formula here to get the $1,806.11. Thank you for correcting me. So when we get down here to monthly, how many times are we going to calculate it? Going to calculate it 12 times. There's 12 months in a year. What's our percentage rate going to be? 1%. Again, 12 divided by 12 is 1. When we set this up, it's going to be 1,000 times 1.01. We're going to calculate this 12 times a year. And then when we go over here to calculate it, to type it into our calculator, we have 1,000 times 1.01 close the parentheses, to the 12 times 5. We get 1816 and 70 cents. We have to round. Remember, money round to the nearest hundredth. So 18, 16, 70. So can we come up with a generic formula here after looking at these four? It says try to write the expression using only variables for the account balance A. So our account balance A is going to be, well, we start with whatever we're going to owe. And that says on an initial charge P. And then what we did is we did 1 plus, we did a rate. So whatever our annual percentage rate is here. But what we had to do is we had to divide that annual percentage rate. If it was semi-annually, we divided by 2. If it was quarterly, we divided by 4. If it was monthly, we divided by 12. And then we multiplied, or we raised it to the n, the number of times it was calculated, times the time period. There's our formula. But what happens here, if you look back at that table, the credit cards want to make as much money as possible. And the way that they're going to make the most money, because all of these are involving the same amount, the $1,000 and the APR of 12%, the way they're going to make the most money is if they charge monthly. So that's what they do. How am I going to make the most money? I'm going to charge monthly. So if we go back to this formula here, the principal's not going to change. Our rate's not going to change. But what is going to change here is that this is going to be 12. And this is going to be 12. When the credit card charges. So if you happen to have a credit card right now, there's your formula. But as we look over here, sign out, take the pass. So when we look over here, the idea behind compound interest, it's interest calculated on the initial amount, but it's also calculated on the interest. In other words, compound interest can be thought of as interest on interest. And it makes the deposit or the loan grow at a faster rate than the simple interest, which is interest only calculated on the initial amount. You might have done in elementary school or at Willis, I equals P times R times T. That's your simple interest rate. The rate at which compound interest accrues depends on the frequency of compounding, and based on the table above, it appears that as if the greater the number of compounding periods, the more compounding periods, the more compound interest. Again, if you go back to our table that we just filled in, we had 1,700 and some calculated annually. And then we had 1,800 and some calculated monthly. The more we calculate, the more money. There's actually two types of ways to calculate interest. The one that we just did, interest is compounded in specific intervals, annually, semi-annually, quarterly, monthly. And when we use that, that's the formula that we just came up with. And A is the total amount in the account. is the initial amount, how much we started with. The interest rate, we need to convert it as a decimal. And then n is the number of times that we compound the interest. That comes from the annual, the semi-annual, the quarterly, the monthly. And then how much time is the t. But there's another way to calculate interest, and it's compounded continuously. And what happens is it's continually calculating interest. So it calculates interest, and then it goes back and it calculates interest again. And then it goes back and calculates interest again. And then it goes back and calculates interest again. It's going on all the time. Like population growth. Unlike a bank account, the compounding of population growth does not take place annually or quarterly. People are being born, people are dying all the time. Every second of every hour, people are being born and others are dying. Thus, the growth rate, the overall effect of those births and deaths can be viewed as a continuous process. And the formula for that is over here in the right-hand part of our table. And it's A equals P E to the RT. A is still the total amount on the account. P is still the initial amount. R is still the interest rate expressed as a decimal. And T is still time. But remember that E is a number. And we can calculate it on our, or we can find it on our calculator. We can go to second and the division bar and enter. If you have an Inspire, then you would go, you don't have to press second on your Inspire, but you would get to the E, and you'd have E in this exponent spot. You have to type 1. And either way, we get 2.718 as an approximation. You need to remember that E is a number. So as we look at our final examples here, we need to decide how the interest is compounded. And once we decide that, then we can use our formula. So it says you owe $200 on a debt with 16% APR. And it's compounded monthly. So first of all, in my opinion, that's the most important thing, the compounded monthly. Because are we calculating at a specific interval, or are we continually calculating? And this calculate monthly means that we're calculating at a specific interval. Then what we want to know is how much will we owe after 2 years if no payments are made. So which of these two formulas are we going to use? The first one or the second one? The first one. So I'm going to circle that. And then we're going to fill it out here. We have $200 that we're starting with. That's our initial amount. And then it's going to be increasing. 1 plus. Our percentage is 16%. And 16% therefore is going to be 0.16. Compounded monthly. How many times a year are we going to be calculating? Monthly, it's going to be 12. And then finally, we're going to take that 12, as it's running into my other work here, 12, and it's asking how much will we owe after 2 years. Just going to write it down below here a little bit so that we can see it a little bit better. 1 plus 0.16 divided by 12 to the 12 times 2. And if we want to calculate the balance, and we do want to calculate the balance, that's what we're going to type into our calculator. It's going to be 200 times 1 plus, I'm going to use my fraction button, and it's going to be 0.16 divided by 12, close the parentheses, to the, and then it's going to be 12 times 2. So here's our value. Remember, once again, money is rounded to the nearest hundredth. So when we fill this in, we're going to get $274.84. That's our account balance. When we look at example number 2, you deposit $1,000 in a college fund that pays 1.2% interest, compounded continuously. Look for compounded continuously. That's the key words here in this sentence to help us identify which formula we're going to use. So it says find the account balance after 5 years. So we're $1,000. We're going to deposit in the bank. That's our original amount. E. And sorry, I gave it away here because it's compounded continuously. So we need to use this formula. PE to the RT. Our rate is 1.2%. But I just want to take a moment and talk about how we write this as a decimal. We're going to take that value and we're going to move the decimal 1, 2 spaces to the left to get our percent written as a decimal. So this is 0.012 when we move that. So 0.012 and after 5 years. So we get the A equals that. And once again, what we need to do is we need to multiply, or we need to type it in our calculator. And we get 1,000 E second ln to the 0.012 times 5 years. That's going to tell us how much money is in our account after 5 years. If we don't touch it, we end up with $1,061.84.